Okay, this is page 10 from chapter 6. Problem 2, they want the amplitude, period, phase shift, and vertical shift. First thing I'm going to do is rewrite this. And the reason I'm rewriting it, because I don't like the form it's in. I really don't like it. I don't like it at all here. So I'm going to rewrite it. So that's sine. And I'm going to put the 4 in front. And what would be left is theta minus. And we want to write something that's equivalent to this, that's in better form to establish what the phase shift is in the period. So 4 times theta is 4 theta. What goes here would be 4 times blank. That would get me equivalent to pi. And that's going to be pi over 4. So this is what I'm looking at. So we would say the amplitude's the number in front of the trig function. That is 1. The period is 2 pi over 4, which reduces to pi over 2. The phase shift, it says theta minus pi over 4, so it's pi over 4 to the right. And there's no vertical shift. So for sine graphs, if the period's pi over 2, those would be the endpoints. Midway between these, if you add these and take half of that, that's pi over 4. That's half of pi over 2. If you add these two and take half of pi over 4, that's pi over 8. And then the last one, if you add these two, you could find a common denominator, which is 4. So that's 3 pi over 4. But then we've got to take half of that. That's 3 pi over 8. These would be my 5 main points. But the graph is shifted pi over 4 to the right. I'm going to add that to each value. And if I add these carefully, I'll have my 5 new points. So I'm going to get pi over 4, pi over 8 plus pi over 4. If you find a common denominators, pi over 8 plus 2 pi over 8 or 3 pi over 8. Pi over 4 plus pi over 4 is 2 pi over 4 or pi over 2. Here, 3 pi over 8 plus pi over 4 is like 2 pi over 8. That's 5 pi over 8. And then the last one, pi over 2 plus pi over 4 is like 2 pi over 4, and 1 pi over 4 is 3 pi over 4. So if we plot these points, and again, this is to the right of the origin, they're positive. It's going to look something like this. And the max and min are 1 and -1. And this is a sine graph. Sine graph starts at the x-axis up to the maximum x-axis, minimum x-axis. So here would be the graph under a phase shift of pi over 4. And here the amplitude is 1, period is pi over 2. Example 3, y equals 3 sine theta plus 2. Amplitude's the coefficient in front of the trig function, that's 3. The period would be 2 pi over 1, which is the coefficient in front of theta, that's 2 pi. There's no phase shift, there's no parentheses, and the vertical shift is up 2. So what we're going to do here is this. We're going to plot these 5 points. Midway in between is pi. Midway between 0 and pi is pi over 2. Midway between here, pi, if we add pi plus 2 pi and take half of that, that's 3 pi over 2. And what I'm going to do is this. I'm going to lightly plot the graph as is, and then I'm going to bump them up 2 because there's a vertical shift. So it's a sine graph, so it would look like this. X-axis, maximum, x-axis, minimum, x-axis. So normally I would just connect them, but there's a phase shift up 2. So I'm going to take each point and bump them up 2. I'm going to use a different color in red here. The reason I'm going to just connect the dots that are in red. And then if I do connect these, I would get the graph with the vertical shift incorporated. That would be problem 3 from page 10. 4, again, I didn't write this, but I don't like the form that it's written in, so I'm going to rewrite this. If it says theta over 4, I can factor out a 1/4. And what would be left is theta plus something. So 1/4 times 4 pi would be pi minus 1. So you could check it by distributing. This should be equivalent to what was given, and it's probably easier to figure out all these characteristics. Amplitude is the number in front of the trig function, that's 2. Period is 2 pi divided by a fourth, that is 8 pi. Phase shift is negative 4 pi, and the vertical shift is negative 1. So my 5 main points would be these, up to 8 pi. They're going up by increments of 2 pi, but I've got to subtract 4 pi from each of these because there's a phase shift. And some people do it different. They graph the original one and then shift them over. I'm more of a fan of first finding the new points and then just graphing it as is. And if I do, these are my 5 new points. So I'm going to plot these right now on the x-axis. And my scale on the y-axis is just going to be this. Here, this should be over here, 4 pi. It's up 2. So here's 2 and negative 2. And then eventually I'm going to bump these down 1. So cosine graphs start up at the amplitude, then to the x-axis, then to the minimum, x-axis maximum. But I've got to bump them down 1. So I'm going to actually use my red pen again, bump each of these down 1. So now the new min is negative 3. And if I connect in red, I'll have the graph. And it would look like this. So these are the notes from chapter 6, page 10.